Hello, Algebra students. Miss Collins here, and today is our first day of our next chapter, and we're going to start off with section 2-1. All right, so today what we'd like for you to be able to do is to solve an equation of one variable with one step. So all of these, you just have to do one operation, and then you will have your equation solved. We have some addition and subtraction properties that I want to talk to you about. And basically what this says is if you add the same number to each side of an equation, it results in the same equation. Now, what I want you to remember is equal sign means the same or balanced. So imagine that you have a teeter-totter, okay? And right here is where the equal sign is. And you have an X on this side and an X on that side. Okay, if you add 2 to this side, well then you have to add 2 to the other side as well. You remember with a teeter-totter, if you want it to stay completely balanced, whatever you do to one side, you have to do to the other. Well, that's the same way with an equation. Wherever your equal sign is that point of balance. And when you add a box or a weight or a person to one side of the seesaw, you have to do the same thing to the other. Otherwise, it will kind of go lopsided like that or like this, according to what side you added or subtracted weight from. So the same thing works with subtraction. If you subtract one thing from the left side of the equation, then you subtract the very same thing from the other side. Okay. So what I would like you to notice in each of these examples right here and here, they did the inverse operation or the opposite. And that's used to isolate the variable. Well, what does isolate mean? Isolate means to get alone. All right, so these are the 4 inverse operations that you have. Addition is opposite from subtraction. Sorry, just like subtraction is opposite from addition. Down here we have multiplication is opposite from division, and division is opposite from multiplication. Now let's look at a couple examples. So it says, what is the solution to x plus 13 equals 27? Well, notice right here is where my equal sign is. So if I take something away or add something to the left side, then I have to do the same thing to the right. To get this x all alone, I need to do the opposite of what I see. Well, this says x plus 13, so to get rid of that 13, I'm going to subtract it. But I subtracted 13 from the left, so I also subtract 13 from the right. They cancel. 13 minus 13 equals 0, and I'm left with nothing but x on the left side. So I'm just going to carry that down. X, carry down my equals. 27 minus 13 is 14. And there's my solution. Notice one step. I subtracted 13 from both sides, and then I got my answer. For problem B, it says, what is the solution? Y minus 5 is equal to 8. Well, go to the side with the variable. And here, I'll mark the equal sign one more time. So we have the left side of the equal sign and the right side of the equal sign. Left side, y minus 5. Well, to get rid of a minus 5, I'm going to do the opposite of subtraction, which is addition. So I'm going to plus 5. Since I added 5 to the left, I now add 5 to the right. And I get y is equal to 13. All right. For the next problem, it says, what is the solution to z plus negative 3 is equal to negative 10. If you want, we can rewrite this problem so we don't have that funky negative number in there. And adding a negative is the same thing as subtracting a positive. So we can rewrite this as z minus 3 is equal to negative 10. Now that I've rewritten it, I see now that the opposite of subtracting 3 is adding 3. So I can add 3 to the left and add 3 to the right. 3 minus 3 is 0, but don't forget I'm left with z right here. So I have z is equal to negative 10 plus 3. Well, the negative 10 is the bigger number, so I know my answer is going to be negative. And then if you go 3 in the positive direction, it's going to get me negative 7. So z equals negative 7 for that one. In our last example, we have some fractions. You're going to see fractions a lot in this class, and don't let them freak you out. They're really easy to work with. We have 1/2 is equal to c minus 5/2. Well, we're going to do this the same way we would if this were a whole number. What's the opposite of subtracting 5/2? Well, it's adding 5/2. So I'm going to plus 5 over 2 because I did that on this side, and if you need I can draw a line for you. And then I also need to add 5/2 to the other side. Okay. 5/2 or negative 5/2, sorry, plus 5/2 is equal to 0, and I'm left with c on the right side is equal to, well, 1/2 plus 5/2 is 6/2. So 6/2 equals c. That can be reduced, so if you said c equals 3 as well, that would be correct. All right. Moving on to the back side of this page. We have one more example. What is the solution to negative 7 is equal to a minus negative 3? Okay, because we have a minus negative, we're going to go ahead and turn that into plus a positive. That's just rules of adding and subtracting integers. So I'm going to rewrite this now as negative 7 is equal to a plus 3. At this point, you should be able to see the opposite of adding 3 is subtracting 3. So I'm going to subtract 3 from the right side of the equation, and I'm going to subtract 3 from the left side of the equation. 3 minus 3 equals 0, but I'm left with the a, so I'm going to carry that down. Negative 7 minus 3. Well, I'm at negative 7, and I'm going to take 3 away from it, becoming even more negative. So this is going to become negative 10. We also have this thing called the multiplication and division properties of equality. These work the same exact way. If you multiply by the same number on the left and right side, then you get the same equation, just like if you divide by the same number. So, once again, we have our teeter-totter. And right here is our equal sign. Our equal sign is saying the left and right is balanced. So if we put two, I don't know, tennis balls on the left side of the seesaw, well, if I don't add 2 more to the right, then it's going to go heavy. So I have to put 2 over here. If I were to divide this in half, meaning I took half of those away, well, I have to take half of them away from the right side as well. If I were to, I'll do one more example with the seesaw image. Here's my equal sign, and let's say I have a couple boxes. I have 2 boxes on either side of my seesaw. It's perfectly balanced. but I want to multiply the left side by 3. So now 2 times 3, I'm going to get 6 boxes total. So now I have 6 boxes stacked up on the left side. Well, if I don't do the same thing over here, my seesaw is once again going to go boom, like that. It's not going to be even anymore. Well, just like in a seesaw, we have to do the same thing to both sides of an equation. So 6 boxes on either side. Always the same operation with the same number on the left and right side of the equation. Let's look at some examples with that now. So we have, what is the solution to 4x is equal to -8? Well, 4 right next to an x means multiplication. The opposite of multiplication is division. Now, I don't want you writing out divided by like that, okay? Remember, a fraction bar means division. That is super duper important. Fraction bar means division. We're going to use that over and over and over. So instead of writing the division symbol like this, we're going to put a fraction bar underneath of it and divide by 4. Because I divided by 4 on the left side, I have to divide by 4 on the right side. Well, 4 divided by 4 cancels out, getting me 1, which leaves me with x is equal to -8 divided by 4. Well, a negative divided by a positive is going to be a negative, and 8 divided by 4 is 2. Notice, once again, all I had was one step. I just divided by 4, and then I found my answer. Next it says, what is the solution to -12 is equal to -16x? Go to the side with your variable, and -16 is right next to the x, so that means multiplication. The opposite of multiplication is division. So I'm going to divide by -16 on the right side and the left side. Here's my equal sign. Well, they cancel on the right, and I'm left with x. A negative over a negative is going to result in a positive number. We have 12 over 16, and that can be reduced. I don't want you to just put that into your calculator and get a decimal. Instead, ask yourself, what can go evenly into 12 and 16? Well, the answer is 4. So if I reduce the top and bottom by a factor of 4, I'm going to get positive 3/4 for my answer. Next it says, what is the solution of 19 is equal to r over 3? Here's where that fraction bar equals division is important. Remember, fraction means division. So now we can read that as 19 is equal to r divided by 3. Okay. To get a variable alone or isolated, we do the opposite operation. Well, the opposite of division is multiplication. So I need to rewrite this down here so I have a little more space. The way that you can write multiplication is by just putting parentheses around the number you want to multiply by. And you're going to do that, once again, on both sides of the equation. So now these two 3's are going to go away. They cancel each other out. And then I have 3 times 19 on the left, which is 57. So 57 is equal to r. On the next one it says, what is the solution of -x over 5 is equal to 11? I'm going to rewrite this. When you have a negative number in front of a fraction, it can be, you can attach it to the top or bottom. It really doesn't matter. It's the same thing. So I'm going to rewrite this as x over -5 is equal to 11. This is the same exact thing as this one. I'm just writing it a little bit differently so that it's a little bit easier for us to solve and make sense of. So now I have x divided by -5. Remember, the opposite of division is multiplication, and I'm trying to get this x all alone. So I need to multiply by -5 on the left side and -5 on the right side. These are going to cancel at this point, and we have x is equal to -55. One more time for good measure. Remember, whatever you do to an equation on the left side, you must also do the same thing to the right side. And to get a variable alone, you have to do the opposite of what you see. We have just a couple more problems, and then we'll be done. It says, solving equations using reciprocals. When you have your variable and it is multiplied by a fraction, instead of dividing by that reciprocal, you should multiply by its reciprocal. I am going to highlight that because that is really important, and this is going to be one of the hardest things for people to remember. First of all, what's a reciprocal? Let's go down here and talk about that real fast. A reciprocal is a fraction flipped. So if I have the fraction 2/3, its reciprocal is 3/2. If I have the fraction 7/10, its reciprocal is 10/7. If I have the fraction 4/9, its reciprocal is 9/4. Whatever you have, flip it upside down. The reciprocal is going to be very valuable all throughout algebra. So, letter J says, what is the solution of 4/5 x is equal to 28? Okay. Here is my equal sign, and remember, once again, whatever you do to this left side of the equal sign, we must also do to the right side of the equal sign. When you see a fraction like this, to get rid of it, multiply by the reciprocal. So first of all, what's the reciprocal of 4/5? Well, it's 5/4. So I am going to multiply, I'll have to squeeze it in here, by 5/4 on the left, and by 5/4 on the right. When you do that, these 5's cancel and these 4's cancel. I'm left with nothing but my variable, which is x. Then we have 28 times 5/4. Well, you can stick that into your calculator, or you can do the reduction where 28/4 reduces to 7, and you're going to get x is equal to 35. We have one more word problem, and then we're done with our notes for today. So it says, toucans and blue-yellow macaws are both tropical birds. The length of an average toucan is about 2/3 of the length of an average blue and yellow macaw. Toucans are about 24 inches long. What is the length of an average blue and yellow macaw? Okay, let's start organizing what we do and don't know. So we know we're talking about toucans and macaws. And I'm going to just label those with a letter so I don't have to keep writing them out. Then it says, what is the length of an average blue and yellow macaw? Well, we're trying to figure out what that is. We're trying to figure out what m is. So we're going to solve our equation for m. it says the length of an average toucan is about 2/3 of the length of an average blue and yellow macaw. So one toucan is equal to 2/3 of the macaw. So the toucan is equal to 2/3 the macaw. That's what I was just told in that sentence. But I have two variables and I can't solve this with two variables. So let's see if I can substitute anything in. It then says toucans are about 24 inches long. So instead of putting t here, I'm going to take this 24 and substitute it in for that t because I know its value now. So now I have 24 is equal to 2/3 of the macaw. I have my equation. I'm ready to solve. Now remember, this section is one-step equations, so I should be able to do this in one step. Well, up here in this previous problem, when we had a fraction right next to our variable, we multiplied by the reciprocal. So we're going to do the same thing here. We have 2/3 times m, so to get rid of that 2/3, I'm going to multiply by 3/2 on the right side and by 3/2 on the left side. So my 3's go away and my 2's go away. And I'm left with m on the right side. Now I have 3/2 times 24, and that is going to get me 36. So that means it's about 36 inches long, the beak of a macaw. That's everything for this section. Hopefully you're understanding one-step equations, and tomorrow we'll be practicing them in class.